Did you know that Mercury and Venus are the only two planets in our solar system that have no moons? Now, that might seem like an insignificant detail for our first mind-blowing fact, the moonless planets. But when you consider that there are 176 confirmed moons orbiting other planets in our solar system, it becomes a lot more fascinating. But before we head there, don't forget to like and subscribe for more amazing space facts. Let's take a moment to ponder this. Some of these moons are even larger than Mercury itself. Jupiter, for instance, boasts a staggering 79 moons, 4 of which are larger than our own moon, and then there's Saturn, with its 62 moons. Even Mars, our closest, has 2 moons of its yet. When we turn our telescopes towards Mercury and Venus, we find nothing. No moons, 2 solitary planets, spinning on their axes, utterly alone in their orbits. Mercury, the smallest planet in our solar system, and Venus, our closest planetary neighbor, have no companions in their celestial dance around the sun. They are the moonless planets, the cosmic loners. If you enjoyed these facts, make sure to like and subscribe. It's an intriguing aspect of our solar system, a reminder of the diverse and often surprising nature of cosmos. It makes you wonder, doesn't it? What other fascinating secrets are hiding out there in the vast expanse of space? Just imagine. Out of all the celestial bodies in our solar system, these 2 planets are utterly alone in their orbits. Next, let's take a look at stars and black holes. Stars may seem invincible, but when they meet a black hole, it's a whole different story. Now, we all know that black holes are cosmic phenomena, so dense that nothing, not even light, can escape their gravitational pull. But what happens when a star, a celestial body known for its brightness and energy, comes too close to a black hole? Well, for 2 decades, a team of astronomers observed a star at the heart of our galaxy in a precarious tango with a black hole. The star danced round and round, getting closer and closer to the black hole's edge. As it approached, the black hole's gravity intensified, a phenomenon known as gravitational redshift. This powerful gravitational pull started to drain the star's light of its energy. You can picture it almost like a cosmic tug-of-war, with the black hole trying to steal the star's radiance. Over time, the star's light began to dim, as it lost more and more energy to the black hole's insatiable appetite. Stars, it turns out, are not immune to the deadly dance with black holes. They can be stripped of their light, their energy, and ultimately their very existence, so even stars can end up in a deadly dance with black holes. Contrary to popular belief, the hottest planet in our solar system is not Mercury, but Venus. Yes, you heard that right. It's not always about being the closest to the sun. Venus, our second closest neighbor, takes the crown as the hottest planet in the solar system. Now you might be wondering, how can that be? Well, the answer lies in Venus's dense atmosphere. You see, Venus is shrouded by a thick blanket of gases, primarily carbon dioxide, with clouds composed of sulfuric acid. This deadly cocktail creates what's known as a greenhouse effect, trapping the sun's heat and preventing it from escaping back into space. This greenhouse effect is so intense that it maintains a constant, blistering temperature of around 864 degrees Fahrenheit, or 462 degrees Celsius, everywhere on the planet's surface. That's hot enough to melt lead. And it doesn't matter if it's day or night, or if you're at the equator or the poles. Those scorching temperatures are constant. So while Mercury might be closer to the sun, it doesn't have the atmosphere to trap and hold heat. Its temperature varies greatly between day and night. Venus, on the other hand, thanks to its greenhouse effect, keeps its title as the hottest planet. So it's not always about being the closest to the sun. Our solar system has been around for a staggering 4.57 billion years. That's right, billion with a B. It's a colossal number, isn't it? Now you might be wondering, how do we even know this? Well, scientists have used age-dating techniques on the oldest rocks found on Earth, as well as the rocks from the Moon and meteorites. These techniques have given us a pretty good estimate of our solar system's age, but that's not the end of the story. Our solar system is not static. It's evolving just like everything else in the universe. Our sun, the life-giving star at the heart of our solar system, is set to undergo some dramatic changes. Fast forward about 5 billion years from now, and our sun will enter its red giant phase. It will expand, its outer layers reaching out into the cosmos, and as it grows, it will swallow up the inner planets, Mercury and Venus. And what about our home, Earth? Well, in about 7.5 billion years, the expanding surface of the Sun will likely engulf our planet. It's a far-off future, but a reminder of the ever-changing nature of our universe. So, in the grand scheme of things, we're living in a relatively young solar system. We're just at the beginning of our cosmic journey, with many more chapters left to be written in the story of our solar system. Saturn's smaller moon, Enceladus, reflects a whopping 90% of the Sun's light. Quite a luminary in the cosmic world, isn't it? But what makes Enceladus so reflective? It's the icy surface of this moon that does the trick. Enceladus is covered with a layer of ice which acts like a giant mirror, bouncing back most of the sunlight that hits it. You might think that this mirror-like quality would make Enceladus a bright and warm place, but that's far from the truth. You see, reflecting light is not the same as absorbing it. When light is absorbed, it turns into heat, but when it's reflected, the heat goes back into space. As a result, Enceladus doesn't hold onto the sun's warmth. Instead, it's one of the coldest places in our solar system. And just how cold is it? We're talking about temperatures that dip as low as -394 degrees Fahrenheit or -201 degrees Celsius. That's colder than the surface of Pluto. So while it shines brightly in the night sky, reflecting most of the sunlight that reaches it, don't let Enceladus's brilliance fool you. Beneath its dazzling surface, it's a world of icy cold. So while it shines brightly, Enceladus is a cold, cold world. The highest mountain known to us isn't on Earth, but on Mars. It is Olympus Mons, a towering behemoth that eclipses even the formidable Mount Everest. Olympus Mons, named after the home of the Greek gods, is a shield volcano, a type of volcano known for its broad, shield-like shape and gentle slopes made by flowing lava. This Martian mountain soars to an astonishing height of 16 miles. To put that into perspective, if you were to scale Mount Everest, the highest peak on Earth, you'd be climbing just over 5.5 miles. Olympus Mons nearly triples that, but Olympus Mons isn't just notable for its height. This mountain is also incredibly wide, with an expanse that stretches 374,015 square feet. That's roughly the size of the state of Arizona. Imagine a single mountain covering the same area as an entire US state. The size of Olympus Mons is a testament to the unique characteristics of the Martian surface. Unlike Earth, Mars doesn't have tectonic plate activity that can limit a volcano's lifespan. This means the lava from Olympus Mons could keep piling up over millions of years, allowing the mountain to reach its present-day jaw-dropping proportions. So Mars is home to a mountain that makes Everest look like a foothill. The Whirlpool Galaxy was the first celestial object identified as being spiral. A mesmerizing sight to behold, isn't it? This grand cosmic swirl is not simply a picturesque spectacle, it's an intricate dance of creation on a galactic scale. The Whirlpool Galaxy, or M51 as it's also known, is a grand spiral galaxy. Its structure is defined by long lanes of stars and gas, all swirling around a central point. Now these aren't just any lanes, they're dusted with a generous helping of space dust. And this dust, my friends, is where the magic happens. These lanes are not just cosmic highways, they are star formation factories. Picture this: hydrogen gas, the most abundant element in the universe, being compressed within these lanes. This compression triggers the process of nuclear fusion, the same process that powers our sun. And voila, a new star is born. This star in its infancy starts to glow, adding its own light to the cosmic tapestry. In essence, the Whirlpool Galaxy is a massive celestial carousel, a spinning wheel of stars. Each spiral arm is a cradle for starbirth, a testament to the enduring cycle of creation and destruction that defines our universe. So, in the Whirlpool Galaxy, stars are born from spirals of dust and gas. A light year is a lot farther than you might think. It's not a measure of time, but rather a measure of distance, and it's the total distance that light can travel in a single year. Now, to truly grasp this, we first need to understand just how fast light is. Light moves at a staggering speed of about 186,000 miles, or approximately 300,000 kilometers per second. To put that into perspective, if you could travel at the speed of light, You could orbit the Earth roughly 7.5 times in just 1 second. Now, imagine maintaining that incredible speed for an entire year. The distance you would cover is almost incomprehensible. In fact, a single light year equates to about 5,903,000,000,000 miles. That's a 5 with 12 zeros following it. It's a distance so vast that our human minds struggle to truly comprehend it. It's these unimaginable distances that make the universe such an awe-inspiring place. When we gaze up at the stars, we're not just looking into the sky, we're peering across vast swathes of space and time, observing celestial bodies that exist millions or even billions of light years away. So when we talk about space, we're really talking about unimaginable distances. Our home galaxy, the Milky Way, is a staggering 105,700 light-years wide. That's right, the vast cosmic neighborhood we call home stretches over 100,000 light-years from edge to edge. To put this into perspective, a light-year is the distance that light, the fastest thing known to us, can travel in a single year. That's about 6 trillion miles. So, our galaxy's width is nearly 600 quadrillion miles. But let's narrow down to something more tangible, shall we? Imagine a modern spacecraft, one of the fastest things humans have ever built. These marvels of engineering can travel at speeds of roughly 37,000 miles per hour. At that speed, it would take this spacecraft more than 450 million years to travel from one side of our galaxy to the other. That's just about the time when the first complex life forms were starting to evolve on Earth. It's almost 10 times longer than the age of the oldest known dinosaur fossil. It's a journey that would span the lifetimes of millions of generations. So, while we continue to reach for the stars and explore the vastness of space, it's humbling to remember the immense scale of our own galactic home. It reminds us that we are but a tiny part of an immense universe. So, even at the speed of light, a journey across our galaxy is a journey of a lifetime. The Sun is the heavyweight champion of the solar system. It tips the cosmic scales at about 330,000 times the weight of Earth. It's a celestial behemoth that dwarfs our home planet in size and mass. If the Sun were hollow, over 1 million Earths could fit inside it. That's a lot of room for Earths. But the Sun's weight is more than just an impressive statistic. It's the very reason our solar system exists in the first place. You see, the Sun isn't just big, it's massive. And with great mass comes great gravity. This gravity is so immense that it keeps all the planets, including our Earth, in their orbits. It's also responsible for the Sun's intense heat and light. The Sun's massive weight creates enormous pressure and temperature at its core, setting off a nuclear fusion reaction that produces the energy we see as sunlight. And here's a mind-boggling fact. The Sun contains 99.85% of all the mass in our solar system. Yes, you heard that right. Almost all of the mass of our entire solar system is concentrated in the Sun. So, when we say the Sun is big, we mean it's really, really big. From the weight of the Sun, we move on to something that is invisible, undetectable, and yet it makes up about 85% of the universe's total mass. We're talking about the mysterious dark matter. Unlike the Sun, we can't see dark matter, and it doesn't emit or absorb light or any other electromagnetic radiation. So, how do we even know it exists? Well, despite being invisible, dark matter exerts gravitational effects on visible matter, like stars and galaxies. Astronomers observe the motion of these celestial bodies, and they found that their movements can't be explained by the gravitational pull of visible matter alone. There must be something else out there exerting additional gravity, and that something scientists believe is dark matter. But what is it made of? That's a question that continues to puzzle scientists. Some believe it could be made of undiscovered subatomic particles. Others propose it could be microscopic black holes. The truth is, we still don't know. But whatever dark matter is, it's a reminder of how much we have yet to discover about our fascinating universe. So, stay tuned with us as we continue to explore the mysteries of space. If you enjoyed this video, don't forget to like and subscribe for more mind-blowing space facts.